Welcome to this presentation of one of the MPAI technical specifications entitled Data Types, Formats, and Attributes. We are at version 1.4, and this is still published with a request for community comments. So if you have any comments during or after this presentation, please inform either me if it is during this presentation or the secretariat of your comment, and they will be considered by the appropriate group. So what is this standard? This standard is produced by MPAI, Moving Picture Audio and Data Coding by Artificial Intelligence. We are an international, unaffiliated, not-for-profit association based in Geneva. We develop standards for AI-based data coding, and we have a very rigorous development process that I will spare today, but it's quite rigorous and also interesting for its conception. And the second important thing is that our standards have an attached clear IP right licensing framework. They are guidelines for licensing IP rights. So what is specifically this standard? It's a standard that specifies qualifiers. What is qualifier? Qualifier is a data type that provides information about subtypes, formats, and attributes of a data type instance. So you have a bunch of data, and the data themselves, data itself maybe doesn't tell you much, but if you have a qualifier, you can understand a set of interesting things, and the purpose of this presentation today is to make you understand or the data type that we have considered so far, what the qualifier tells you. So one thing is to provide information, say, to humans, but actually the purpose of the qualifier is to provide information so that a processing element, we call AI module in MPAI, has this additional information that lets you perform do a better job. We have the following domains for which we have qualifiers right now: automotive, avatar, health, machine learning, media, metaverse, space-time, and theatrical domains. All these are mostly driven by specific application domain, but we do also have several qualifiers that are applicable to a larger amount of MPAI standards. So first of all, let me introduce briefly the standard that we have developed so far. AI framework, something I will say more, profiles. Compression understanding of industrial data is basically about finance. Then we have connected autonomous vehicles. We have the context-based audio enhancement. We have, the data type, formats, and attribute standard itself. AI-enhanced video coding, upsampling filter for video application is a standard that is published for a request for community comment. The governance, human and machine communication, MPAI metaverse model, multimodal conversation, neural network watermarking, traceability, object and scene description, portable avatar format, server-based predictive multiplayer gaming. So all these standards have been published, possibly with more than one version. Those that are marked in red need qualifiers, and so we will introduce some of the data types of the qualifiers that we have developed for these standards. So this is the list of the new standard on which we are that we're currently developing. As you see, we have 4 out of 5 that need qualifiers. And for the fifth, maybe we don't have qualifier because we are not clear enough about what the standard will be. It's an end-to-end video coding. So the first standard, because it has a big impact on this other qualifier standard. AI framework is a foundational component of our standards. It is made of 3 characteristic elements: a framework, an AI framework, and this is an AI framework is where you run AI workflows, and AI workflows are composed of interconnected components, and they are called the AIMs or AI modules. The AIMs receive data from other AIMs, not just one necessarily. In some cases, we have a few that provide the data to a particular AIM, but they can also simply come from the outside of the current world, which is the AI workflow. So the purpose of AIMs is to apply a specific function to the data received, and then the result is to send the process data to other AIMs or outside of the framework of the workflow. The critical point is that the AIMs can do a better job if they know more about what a particular AIM is connected to or receives the data from. So here is the very general diagram of the AI framework. As you see, we have user agents, we have a controller, we have APIs. This is the AI workflow. This one, as you see, it contains several interconnected AI modules, and here you have a variety of functionalities. The blue ones here are for encryption, but we have communication, we have global storage because we have local storage as well. We have the MPAI store. I don't have time to dwell on this functional, but it's essentially where you can download AI workflows and AI modules. So let's consider a particular AIM. So one that is quite important, I'm noticing that one arrow is missing here. So we have that it is called entity dialog processing. So what is entity dialog processing? So imagine that you have a chain of processing. You have a speech coming in into an automatic speech recognition. The output is, well, the text that has been recognized, and this one gets inside the natural language understanding, and the output of the natural language understanding can be simply text. I mean, the purpose of the natural language understanding is to refine the recognized text and provide a better text that is provided to the entity dialog process. But you can also have meaning. So meaning is what the text is about. So this is certainly additional information that helps a lot in entity dialog processing to provide the answer of the machine. But you can also have, for instance, information about the IDs of the objects on which presumably the text is talking about. Or you can even have the description of this object in a particular scene. So as you see, there is no such thing as having just one AIM with one input and one out, or a plurality of inputs and plurality of outputs, but it depends very much on the capabilities of the AIM. So this is what the AIM profile, it's a standard that we have developed, is the second in the list, that provides information about the AIM capabilities. So, but this is one dimension. This presentation will be about another dimension, which is about improving the performance of the AIM based on the capability that the AIM has. We don't want to change the capabilities on the fly. So the claim that I make is that the performance of an AIM can improve if the AIM knows more about the characteristic of the data received. For instance, visual information is received, and we are providing a color space or information on the color space of the instance of visual data type. Or it can be a speech segment, or it can be a file, and the format of that file is a WAV file for that audio segment. Or we want to provide information about what kind of gamma correction has been applied to the device that produces it, or simply whether gamma correction was applied. The idea of an object in an audio segment. So in an audio segment, maybe you can have information about who is uttering this audio segment, or the text that is embedded in the speech segment. So all this is additional information that you can provide to an individual chunk of data. And data qualifier is the MPAI's response to this need of transmitting additional information. So the standard for qualifier specifies the qualifiers, and this is done to a growing number of data types. This is version 4. The version 1 was simply for media data types. Now we have quite a few more. So a qualifier, then you say, it can say about a video that a given color space is used, and that is called the subtype, is produced by a particular codec format. Let's say that is ABC, and this is the format information, and maybe it includes an object of a given idea. This is an example of an attribute. About 50% of MPAI standard need qualifiers in addition to content information. And as I said before, qualifiers are human readable, but they are intended to be used by an AIM. So the idea of giving information, additional information about a chunk of data is a wide problem. We have another solution to qualify. So the qualifier is something that describes the intrinsic properties of a data type. So when I say a given format, okay, that is the format. I mean, it is intrinsic property of a data type. We have annotation, but annotation is more about describing information that may be changed. It is a spatial information, temporal information, but it is destined to change. The policy is that we publish new version of this standard. If an application standard requires new qualifiers that we didn't have before, or if we need to extend an existing qualifier. And during the history of these four versions, I can tell you that we had example of both cases. So if you have want to extend an existing qualifier, you want to specify an additional qualifier, send your request to the MPAI Secretariat, and this will be considered by the appropriate group. And so another point that I'm making here is that, as you see, this standard is, I mean, it evolves quite rapidly. Let me put it this way. And therefore, versioning of qualifier is critical. But the policy so far has been that we have added new qualifiers or extended qualifiers, and that the extension did not imply a diminution of what was before. So, as I said, the qualifiers is composed by subtypes, formats, and attribute. And each of these elements have a hierarchy. In some cases, we can very well not have subtypes. In general, we have always formats. Attribute is often there, but not necessarily it is there. And the other point is that new qualifiers can be added because we don't claim that the current version satisfies all possible needs of all users. The current qualifiers satisfies the need of the standard, of the MPAI standard at the current level of development. But in 6 months' time, I would guess that we may need more qualifiers, and therefore we will have a new version of this standard. So here we are at the core, because these are the qualifiers that we have for automotive, for avatars, for health, machine learning, media, metaverse, space-time, and theatrical. So let's see something. In automotive, we have ultrasound. So let's see what it is. So we go to a page. So each qualifier, each data qualifier has a particular page for the ultrasound. We have this, we have a definition, we have the functional requirement, we have the syntax. I'm going to have a look at it. And then we have the formats. The formats are the common ultrasonic data file format and the ultrasonic file format. So let's have a look at what the JSON file gives you. So this is just a standard structure of our of all MPAI data. So we have a header, the ID, the qualifier. We don't have subtypes. We have a format, and the format, well, the format is given by an enumeration, not a long one, but we do have oh, I did not copy entirely. Okay, so it simply says that, okay, we have an enumeration and we have the two data types that I have mentioned. Let's have another look at mocap qualifier, if you want. For mocap qualifier, we have the same thing. And here we have a long, long list of different formats. We have about 20, actually 24 formats. And, you can say that you have mocap data, but then you can say that the format is ASK. That is what we can provide. Okay, let me go back to. So for the metaverse, we have the contract qualifier. So the idea is that, of course, in the metaverse, you have plenty of qualifier of contract. And for the MPAI metaverse model, it's another standard and published for community comment. We do have a need of contract. We have something that is called a simple contract. Because it's good for the needs that we have for basic type of transactions. But we do list other contract that may be needed in that context. Let me see. So this I go for media. So let me take audio, for instance. So we have the definition, the functional requirement, we have the syntax, we have the semantics. So we don't have subtypes for audio. We have therefore format, and format is divided in content. So the format of the audio content itself, and here we have different things. So we have, for instance, spherical money decomposition. We have ambisonics. So we have a need up to the 7th order in the audio standards, binaural, different compression formats. And then we have also transfer formats. So here you can signal that your file format is WAV, or it is a core audio format, or it is MP4. And if it is a stream, that it is Dash or it is HTTP live streaming. For attributes, so this is a very rich description because we have different source types. Can be vocal, can be music, sound effects, it can be noise. For metadata, we have Dublin Core, ID3, IPTC, and others. So then spatial attributes, so this is quite a rich description. We have binaural cues, we have spectral cues, interchannel differences. We also have the possibility to define the device that has produced the audio object. And so we have the sensor geometry. The sensor geometry is described by the microphone array geometry, which is an MPAI data type. So here you will see the specification of, we can say, quite a few interesting things. So array scat, calibration, by equalization, and so on. Let me go back to where we were. Then we have the device geometry. So you can have different devices capturing the audio object. So this is something that we need for the 6 degrees of freedom audio standard that we are developing. We have the sensor characteristic, different types of microphones, the frequency response, and so on. So here you have an example of a quite rich description. I could go, but this time I would be quicker, to visual. So here we have the same. It is, in a sense, more complicated. So because we have subtypes here, and the only subtype that we consider, I believe, is the color. And we have, we also have the color formats, the alpha channel, brightness, YUV, or color subsampling, different types, YMCK. Then we have the formats in the sense that I was saying before, when it is just represented by sampling, or when it is 2D, when it is 3D. And here, as you see, we'll have in the case of 2D, so we have, for instance, JPEG, We have also SVG, TIFF. If it is dynamic, then I mean video by this. We have AVC, we have AV1, EVC, HEVC, LCVC, VVC, and I'll stop here. For 3D, we have bounding box. This is something that is defined by MPAI, OBJ, FBX in the case of the dynamics. For transport, we have different files and different streams. We have different attributes. Attributes, we have real and synthetic, for instance. Then we have different metadata devices. And so, as you see, it is something that is very, very rich and detailed and satisfies the needs of our standard. It doesn't mean that this is what we the only thing that we can provide. Trying to get back to the page. Okay, let me see. After this, we have so for instance, for the three article, we have dense qualifier. So dense qualifier is quite interesting because this is a set of data providing additional information on the limb movements of dancing humans or avatars for potential use by a machine. So the dense qualifier is attached, is part of the dense object, which is specified in this standard that is still being developed. And the structure is the same. In this case, the format are, I mean, it's a reference. The format themselves are quite rich of information, but we simply point to this format. We don't put our hands in Benesh and in Lemma notation. Yeah, so let me go then. If you need additional entries, you write to the MPAI Secretariat. Our work is summarizing the different pages that you have seen. So each entity that is part of a specification has its own web page and also its own JSON schema. Therefore, I can direct you to the specification, which is available at this page. So the structure is always the same: MPAI.community standards. This is the acronym of the standard, TFA, and this is the version. And therefore, I'm looking forward to welcoming you in this MPAI project. This is the web page where you can get information on how to join. And if you join, I can tell you that we will share with you the fun that we are having, and we will build the future together. With that, I think I can stop this presentation and